Welcome to the lecture series on the deep learning. Today we are going to see the introduction of the deep learning. This is Praveen Kumar, Assistant Professor from VFSC at DMITB University. Let's see the prologue of the deep learning. So, deep learning is sub-branch of the artificial intelligence and machine learning. So, let us see that what is this artificial intelligence. Artificial intelligence is a broad branch which talks about the ability of machine to imitate human intelligence. So, the scientists want that the machines to be given the ability to act like a human being. So, this is what they have expected, and with that thought this concept came into the picture, artificial intelligence. And from that sub branch is developed called the machine learning, where the mathematics algorithms have been prevailed. So, algorithms to incorporate intelligence. So, in order to intelligence this artificial intelligence, because natural intelligence is going to be there with the human beings only. So, to provide this artificial intelligence and how to provide this one to the machines is the concept here. So, in machine learning, various algorithms and mathematical concepts have been used to build or to develop this intelligence or to incorporate the intelligence into machine by automatically learning from the data. And here this data is also have become very important point here, because human being also learns from the data only or information. So, here the machines should also learn from the data. So, that is why data and the algorithms both have become important here. So, these algorithms are going to learn this data, and with this data they are going to get some intelligence. And what we can say about this intelligence? Intelligence is mainly to take some decisions or to react for the things. That is what the intelligence. How to react when something is happening, and even predicting something, that foresee what will happen in future. Okay. So, such kind of things are called the intelligence, and those are we cannot do it 100%, but maximum we can try to achieve that 100, or we can move close to that one. So, usually human intelligence you cannot predict it, but this machine intelligence is possible that one. Okay. So, how much data you are going to give and how much the algorithm efficiency is there to understand this data, and how much intelligence is achieved, we can measure it as it is coming from the machine and algorithms only. So, few years this machine learning concept has prevailed a lot and it worked very well, but the results were up to 70% only, not closer to even 80 or 91. So, this was not so happy moment. So, later to improve this learning concept, because algorithms have to learn from the data. So, that is the link. Algorithms have to learn from the data to get the intelligence. So, algos have to learn from data to get intelligence. This is nothing but artificial intelligence. Okay. So, this is what the concept. Okay. So, to improve this one, what they thought is that this algorithm have to mimic human brain. So, they have ultimately identified that what is the core thing is there with the human beings, such that the human beings intelligence is more high. They have tried to understand this one. So, and they have understand that So, this human brain is a mix of the billions of neurons. So, the concept neuron came into the picture, and they have started working towards that neurons, and ultimately with the help of that artificial neurons they have started building this more intelligence systems, and that is what they called it as deep learning. So in machine learning, actually something surface level it happened, okay. When we understand that one how human brain is working and the human brain structure is understood, and based on that one algorithms have been developed, and that kind of knowledge or that kind of subject they called it as deep learning. But ultimately this is also the same concept. There will be algorithms and there will be data, and through this data the algorithms will learn, and ultimately the intelligence is going to be achieved by the machines. So here the criticality is that one, what level of algorithms here we are using. Either they are mathematical algorithms, or with the help of the algebra, or with the help of the calculus, with the help of some mathematics we are going to learn the data, or else with the help of the critical structure like human brain architectures like neural networks, and using those networks understanding the data and getting the intelligence. So that's what about this deep learning. So let's focus something on the differences between the machine learning and the deep learning. Come to the features part. Here feature is nothing but if a human being has to understand something, first understand some object, the human being has to understand the features of that particular data or object. For example, if the human being is trying to understand a chair, so chair is having certain properties or features, like it is having some legs, okay, and hands, and okay, resting part and seating part. So this way, so some properties are there. That way, for any data in real life, that's to understand about the weather. So weather is having some moisture is there, some pressure is there, okay, some pH values, some properties are there for that one. Heat is there, coolness is there, how much is there, this much. So this information is there. Based on this one, the human being is going to understand it, and based on that one he is going to do some predictions, some intelligence is going to be generated from his brain. So that way machines have to understand the data with the help of the features. So here the features to be understood in machine learning and deep learning, okay, are in a different way. Okay. So when it comes to the data level feature, machine learning, so it can handle small to medium sized data only. These algorithms cannot able to understand or process the large amounts of data. Large amounts in the sense gigabytes and beyond the gigabytes, terabytes and the petabytes of data. They will be good with the medium sized only, hardly gigabytes or megabytes of data only. But when it comes to this deep learning part, they are capable to understand the large volumes of data, like terabytes of data. And then come to the feature engineering part, how these features are extracted. When it comes to this machine learning, user himself has to define the features and need to extract with the help of the special functions, and that information has to be given to the machine learning algorithms. Whereas in deep learning, there is a special mechanism called the back propagation. You are going to learn about this one in future videos. Through this back propagation mechanism, the features are going to be understood automatically, or they are going to be designed. So that's why in deep learning we need not to figure out the features exclusively. Okay? When we give the data, and if you design the neural network properly, and if you apply that algorithm, back propagation algorithm, that algorithm will take some time to understand the deep features of that particular data. So that is why the feature engineering is not exclusive in the deep learning, but in machine learning it is exclusive, or we are calling it as manual. And when it comes to the complexity, here this complexity is simple algorithms only we are going to use, that human being can able to solve through the pen and paper, and easily he can interpret that one how this output is came. But when it comes to this deep learning one, so here as I have told you, we are going to use these neural networks. You will see in further slides what is a neural net, and this neural network also in multi-layered manner. Okay. So many layers we are going to arrange this neural nets. So, because of this one also understanding the deep learning is going to become difficult. So, that is the different part. Then the computation is going to be its low level in machine learning, and in deep learning this is going to be high level computation are required, because as many connections will be there and many operations are going to happen. When it comes to the performance, it is good for the structured data, okay, and this deep learning is very good, or it works very well with the unstructured data, because here structured data in the sense almost the features are fixed one. We ourselves are being manually we are going to define that what is the column 1, column 2, column 3, column 4. That way arranging is called the structured data. So, those columns can be nothing but the features. So, feature 1, feature 2, feature 3, feature 4. So, this way what is that particular feature and what is the values are available to that one, we are going to define it. So, understanding the data will be very easy by the machine learning algorithms, and it works very well with this structured data. But when it comes to this deep learning, here as I have told you, the features are automatically extracted. The feature engineering is automatic here in deep learning. So, the data when you give, so from the data the features are going to be extracted by the algorithms like neural network algorithms, and mostly the data is going to be not a structured format. Here it means that it is not going to be in a tabular format. We are not going to define it clearly that this is feature 1, feature 2, feature 3. We will give the some unstructured way of data, and from that one it captures the structured features and it understands well. So, with that one, so the deep learning is going to work very well with the unstructured data, it excels. And when it comes to the interpretability, interpretability means how the outcome came, understanding it or interpreting the result, that why this result we got, because of which features we have achieved this result. So, understanding this is a bit difficulty in the deep learning. That is why interpretability is low in deep learning, it is high in the machine learning. Machine learning algorithms are not so critical, because of that one it is a bit easy to interpret what is happened in that algorithm. But when it comes to the deep learning, because of the multi-layer neural networks, so clumsy networks will be there. Because of that one, which network or which neuron has contributed to get this particular output, figuring out is going to be difficult. Right, that is about the machine learning versus the deep learning. Okay, let us come to see the core element of the deep learning. Okay, this is neuron. It's a core element of deep learning networks. Okay, so neuron. So, a bit history about this neuron, how this neuron looks like. Actually, neuron term is related to the biological thing. It is a very element, basic element of our brain. So, this is going to be the structure of the neuron. So, there is going to be some cell body, and here are the connections, edge connections. These edges will receive the information. Most of the cases this information you will get from the 5 elements of human being, like eyes, nose, skin, tongue, these things. Okay. From this one the information is going to be transferred. Once it is transferred to these points, this information is passed to the center point, and ultimately here this is the nucleus, and here some process is going to happen. Actually, it is not possible that for the human beings or the doctors that what type of chemical reaction is happening here, okay, but some processing is happening, and that is going to produce some output, and this output is passed to the next neuron, okay, through these edges, and again same structure will be there here, okay, and these are connected to that one, and this is a big network of the neurons. So, this way So, they have identified that, they named it as the dendroids and the nucleus and cell body, axon and axon terminals, okay, and these are connected to the next neuron, and again there will be cell body and nucleus, axons, dendroids. So, that way they are going to be connected. This information will be passed, and ultimately once this cell body gets some amount of information, okay, which is enough to react, then from that particular point, so it gives the instructions, it means the brain gives the instructions to your external elements for your limbs, either legs or hands or, okay. So, these body elements, and those will react. So, some output you are going to get. So, ultimately through the sense elements you are taking the input and your brain is taking that one, it is processing until it is going to get some proper information, okay. Once it got the proper information, then the person is going to react it. If you did not get the proper information, so then you won't react, okay. That is what the thing, okay. So, in real life it happens. Similar concept they have taken and they have built this neural network architecture, okay, artificial neuron. So, what they have transmitted is this one. So, these dendroids, what are they are? They are calling as the, okay, so connections, and anyways from the sense elements we are going to get the information, and but here we are going to get somehow the inputs, okay, and these inputs all multiplied with some weights and biases. So, here I have written this, okay, weights, biases and activation function. These are the three elements, very important elements in neural network. So, whatever the input is there, that input is multiplied with these weights and the bias is added and passed through the activation function. These different inputs are summed up here after multiplying with this weight. So, this equation we can write down this way: input is multiplied with weights, okay, and then this information is added with bias. Input is multiplied with the weights and that information is added to the bias, and once this information is formed, up to here you are going to get, and this summation in the sense, this is from input 1, this is weight 1 and this is bias 1, and further it can be input 2 multiplied with the weight 2 and added with the bias 2. So, this way this output and this output, this all are going to be mixed up here, and finally this total information is passed to a function called the activation function. So, this is the part. So, one neuron structure is having inputs, weights and biaster, and they are all multiplied and added and made, they are going to be summed up. This we call it as a weighted sum. Once we got that sum is passed to a function, and that function is going to give you one output. And further this output can be passed to the next levels of the neurons. So, that is the structure going to follow. So, biological neuron terms are soma, dendroid, synapses, okay, myelin sheath. These are all pure biological terms. Related to this one, we can call the weights, biases, activation function. Okay. Then thousands of synaptic connections will be there here, but here limited number of, typically fixed number of weights will be there. So, synaptic connections receiving the signals, synaptic connections, okay. So, this kind of connections, so they will be thousands, actually more number of connections will be there in our brain, which will receive the information from the sense organs. But here, okay, so that many we cannot put, okay, so we are going to use some limited level. Then axon, this axon, okay, transmits the signals to the other neurons via synapses, okay, via through these things the information is going to be passed to the next neurons. But here a signal numerical output based on the weighted sum. Just now I have told you, okay, so the sum of these weights and inputs and the bias is called the weighted sum, inputs and through the activation. So this is going to be activated and that output will be passed to the next neuron. So they have understood the structure of this neuron, the scientists, and they have formulated it into a mathematical formula and made it as a artificial neuron. So who did this one actually? Okay. So in 19th century, okay, so a Spanish scientist proposed this concept, and he told that one a brain is a composition of the discrete units. It is a composition of the discrete units called the neurons. This is the term he coined. Later in 1949, Donald Hebb, okay, he is a famous scientist. On his name a neural network structure is there, Hebbian neuron they will call. Okay. So he has introduced that the idea of learning means that one there is a possibility that through this neuron structure we can teach something or these neurons can learn something. Here learning is nothing but for what input, what output we are expecting. If we both given to the machine has to understand that one for this kind of input always this output is expected. If it understands this one, that is what called the learning. Okay. Like for example, teaching a child tables like 2 2s are 4, 2 3s are 6. So you are teaching him that one when I give the inputs 2 and 3 and multiplied, the output will be 6. So he is going to remember that one whenever I get the input 2 and 3, I need to understand the output of these two is as 6. So this understanding is called the learning. Okay. So this learning is happening. So such kind of things they have identified. It is a very basic level of thing. Then McCulloch and Pitts, these two people have developed a concept, okay, of learning very well, and they have proved that one logic functions or logical gates, AND gate, OR gate, XOR gate, AND OR gate, NOR gate, such kind of gate outputs, they will contain some inputs and outputs. Okay. So this input and output is possible to achieve through the neural network, they have proved that one. So with that one, so the people have believed that one there is a possibility to work with this neural structure. Okay. And later Frank Rosenblatt, okay, introduced a concept called the perceptron. He has started a name called the perceptron, and it is the first artificial neural network capable of learning weights through training. So here the back propagation concept came into actually without that word back propagation, learning weights, learning in the sense adjusting that weights, okay, is possible. They have explained this one, but he failed to provide a solution for this XOR, because XOR is not a linear function. You will see that one what is linear and what is non-linear. Before going to that linear and non-linear, so we will see this example that, so these are my gate structures, logic gate structures. So this is my OR gate, this is my AND gate, okay, and this is the basic perceptron model. With single layer, means only one neuron structure will be there. So that is called the perceptron. So what is the idea is that one, I am going to pass this input 0 and this 0, okay, and I am expecting here the output is this 0. Okay. And how this is going to happen is that this 0 is multiplied with this weight, and this 0, whatever the input is there, is multiplied with this one, and it will get inside to this y, and this y is going to have a function f, and it says that one there is going to have some threshold value. The threshold for the unit is 3 here. Okay. So, the threshold is says that one, if the value will be is greater than or equal to 3, my output is going to be 1, and if it is less than 3, my output is 0. This is my threshold function. Okay. So, very simply they have implemented this structure and they have achieved this OR gate. Let us see this one. Okay. So, when I give 0 and 0, 0 multiplied with 3 will be 0 and 0 multiplied with 3 will be 0, and when I have added this thing at this particular y part, so I am going to get 0 only. So, ultimately it is less than 3, so I got 0. Similarly, here 0 into 3 will be 0, and 1 into 3 will be 1, and 3 plus 1 will be 3. So, which is greater than or equal to 3, it is true. So, I am going to get 1, this output I am going to get. When I pass 1 0, so again 3 into 1 will be 3 and it will be 0, 3 plus 1 will be 3 and it is equal to 3. So, my output will be 1, and 1 1 will be 6 it is, and greater than 3 it is, I am going to get the output as the 1. So, this way what they have said that one, if I multiply this input with this weights concept, this is the important thing. Okay. If I put negative value here, it is not possible for me to achieve this AND gate. If I put positive values only, it is possible for me, and even for the AND gate. So, this one. So, AND gate concept is that when I give 0 and 1 or 1 0 or 0 0, I should get as the output 0. So, for this one, the threshold function is this one. If the value is greater than or equal to 2 only 1, if it is less than 2, it is 0. So, here all logic lies is that one designing this threshold function. So, if the threshold value is less than 2, then only it should be 0. So, if you see this one, when you pass this 0 and 1, and if you keep this weights as the 1 and 1, so 0 into 1 will be 0 and 1 into 1 will be 1, 1 plus 0 will be 1. So, you got the 1. So, that is why here the threshold value we kept that one if it is less than 2, not the less than 1. If it is less than 2, then only it is possible that okay, so I am going to get the 0 for the 0 0, 0 1 and 1 0. And when it is going to be 1 1, so 1 into 1 and 1 into 1, so will be 1 1, 1 plus 1 will be 2. So, it is greater than or equal to 2. So, I am going to get as the 1 output. So, this is going to be achieved. So, here the concept need to understand is that one, these weights and the threshold function both are playing a critical role in learning part. So, need to understand or focus that one, weights and threshold, said that. So, if somehow you manage to identify this weights and this threshold function, it is done that one with your perceptron, it is possible to achieve the expected output. But this was not easy for the XOR. So, before going to that XOR part, okay, so let me see, let me show you once again the structure of the perceptron. So, this is my neuron structure, or I can call it as a single neuron. Okay. And the inputs are coming, this is x1 and x2 and x3, these are my inputs. While they are coming inside to this one, they are multiplying with this weights. As I have told you, these weights are going to transform this input, and once they have received, it means that x1 into w1, when it reaches here, I am going to have my summation signal sign. So, plus x2 w2 plus x3 w3 multiplied. So, this is going to become one particular sum. Even one more element is there. Actually, in perceptron, very first perceptron they have not added, later they have added bias they are calling. So, this extra term is going to be added, bias. These are all to transform the input, okay. And once it is done, it is passed through a threshold function, okay. So, as of now the threshold functions are linear function, but in future we will see that one, okay. So, non-linearity, and finally we are getting this y value. So, what makes this perceptron to achieve this y, expected y, is it depends on this weights. Weights have to be suitable weights, and this activation function or the threshold function to be suitable function, so that that function has to give us the proper output. So, that is why expected one. So, this is the explanation for the perceptron. The person is Frank Rosenblatt, okay. So, he has coined this word, said that one clearly, input should be there, weight should be there, and there is going to be a bias, and this is the function as I have explained you, sum of wi xi plus b, this I am going to call it as a z value, and this z is passed to this activation function. As of now here we are saying that one, it is a threshold function, okay. So, this perceptron works with the mainly linear problems. So, just I have told you so, whatever the equation which we are writing, z is equal to sum of wi xi plus b. This is very much similar to the y is equal to mx plus c. As this is, you know that one, this is a linear line equation or straight line equation. It means that with this equation there is a possibility to achieve that figuring out a slope based straight line, either in this angle or this angle or this angle somehow, okay. So, in one angle you are going to get a straight line, but you never achieve something like this kind of curved line with this one, because this is a straight line equation, okay. And further the activation function which you are passing the z value to that activation function, that is also a simple threshold value, it is not a non-linear function. So, what is the problem here actually, okay. So, in real life the problems can be divided into two categories. One is linearly separable and linearly non-separable or inseparable. It means that two data points are there, and to differentiate these two data points you are going to draw a straight line, and you are going to say that one, above that straight line are going to be data points 1, and below that line you are going to say the data points 2. So, two data points you are going to distinguish by drawing a straight line. So, such kind of problems I can call them as the linearly separable problems, okay. These are all very fair things in real life. Like for example, customers are there, okay, who are purchasing the goods from our shop. So, I wanted to distinguish that one, who are the top customers who are purchasing, okay, so greater than the 50,000, and who are the customers purchasing lesser than the 50,000. So, it is very much clear for me that if I take the data and I can draw a straight line, that one, okay. So, the people who are purchased greater than the 50,000 or the elite or the okay, so best customers, and those who are okay, so below this 50 line are okay, so next level customers. I can divide this one. Okay. Here the condition is very clear, linearly separable one, but when it come to the some issues, some problems, so here we have considered only one feature. Okay. So that is one dimension. Based on single dimension it is possible, or two dimension it is possible for me, but when I have tried to consider that one, okay, I want to figure out the customers, or let us see that one. Okay, so I want to figure out the cancer patients and the non-cancer patients. It is going to be very difficult task that simply you cannot say that when the people who are all smoking or comes under the cancer category and non-smoking or the comes under the cancer category, non-cancer category. You cannot say that one, because it is not there in the real life that one the people who are all smoking or one day they are going to be affected by the cancer. You cannot say this one, it is not proved one completely. So that is the point, but there is a statement that one, okay, so if you smoke there is a possibility that you are going to be affected by the cancer. So you cannot consider that single point, so you need to take the his history also, already do the his ancestors anybody is having cancer or not, and even alcohol also creates chances, or it gives a chances to get the cancer, and even some more points will be there, is health issues or okay, so his lifestyle. So many points are coming here, it means that so many dimensions are coming. So under which dimension I have to consider this person and under which dimension I should not consider is going to be a difficult point. So that is why the line is not going to be a straight line, because if you say that one the people who are all smoking will be cancerous one, and the people who are all, so the people who are all smoking are the cancerous one, and the people who do not smoke non-cancer, if you divide that one, so some people may fall that one, even though those smoke they are not going to fall under this category, and the people who are all not smoking also there is a possibility to fall under the cancer category. So in such situations it is not very straight line to draw this one. Sometimes what you need to do is that when you need to figure out a line this way. Okay, something okay. So as in two dimension it is very difficult to show. So I will say that one, okay, wherever these boundaries are there, before or below this boundary are the non-cancerous people and above this are the cancerous people. So you need to draw this kind of line, and this is not a straight line, so many curves are there. For this one we require the non-linear functions. So the non-linear functions example are sigmoid function is there, okay, 1 by 1 plus e to the power of minus z or minus x we call. When you take the x value and if you pass that x value here and if you substitute into this function 1 by 1 plus e to the power of minus x, you are going to get a curve like this one, S shaped curve you are going to get. Okay. Similarly, there is a function called the ReLU, rectified linear unit. So here that function is going to be this way, it is going to have. Okay. So this way some non-linear functions are there, so they are going to help us to achieve this kind of curved outputs. So that is why when we are going to apply this function, we are going to use this non-linear activation functions. So I will stop it here, and before stopping this one, so let me tell you that one, what is this XOR actually, why this XOR problem has become a non-linear problem. Okay. So what is the truth table of the XOR? See this 0 0 will be 0, 0 1 1 and 1 0 is 1 and again 1 1 is 0. And why this is going to be a non-linear problem? Let us take this as on a scale. So, if a 2-dimensional graph if I have drawn for this one, 0 0 will be 0 and 1 1 will be 0 and 0 1 will be 1 and 1 0 will be 1. This way my data is formed here. Now, I wanted to draw a straight line to separate these things. It is not possible for me, because if I draw a straight line like this to separate the two data points, and here the 1 is falling, 1 and 0 are falling above the line and 0 1 falling the below line. But what we are expecting is that all 0 should be at one line and all 1s should be at one side. Like for example, if I take my OR gate, okay, OR gate what it says, all sides it will say zeros and one side it will say 1. Okay. So, here if I just figure out this line, draw, above this line are all zeros and below this one line is called the 1, it is fine. But here it is not possible for me to draw any line. If I draw this line, okay, so again 1 0 is falling left side and 0 1 is falling right side. I am unable to separate the zeros and ones clearly with the help of the straight line. So, what I require is that something I require, okay, so the line something this way, that beyond this line that side or beyond this line, okay, so this side or the 0 values and below these two lines is considered as the 1. That kind of region I need to figure out with the help of the curved lines. So, to achieve these curved lines we require to have this non-linear functions. Okay. So, the solution for this XOR problem, so we will see it in the next class. Thank you.